state of Oklahoma's introduction to ArcGIS. My name is Annie Cahill. I am your instructor for this course, and I am accompanied by Becca Mangan. I am a GIS technical consultant with Datamark. I've been with the company almost 5 years now, and I run all of our strategic planning and boundary facilitation services, as well as develop a lot of educational courses and workshops for our clients. So, Becca, I'll let you go ahead and introduce yourself.
Hi, I am Becca Mangan. I am a technical manager with Datamark, and I help lead a team of GIS professionals to help support our clients with the GIS services and help execute those contracts that we have with our clients. Been doing GIS for about 9 years now, and definitely excited to get in here and explain.
Yeah, and Becca and I also teach the Oklahoma State NG9-1-1 GIS toolkit, which is really critical for you guys to understand. That's one of the reasons why we're teaching this course. It's not just to give you an intro about GIS, but also to prepare you for getting ready to manage your data in that format that's required by the state models. So Becca and I teach the toolkit. We've also worked with our clients in Oklahoma to help get their data ready. All of you guys are going to have to do that going forward, whether you do it yourself or you hire another vendor to do it. Everyone's got to meet the state standard so that all of your data can be rolled into the state repository. So we're going to go ahead and get started here. So our agenda for today, we're going to give you an overview of what is GIS. We're going to talk about GIS data quality as it relates to NG9-1-1. What are the implications of that if your data is not ready for NG9-1? What are some things that can happen? We're going to talk about some GIS data validations and kind of review the toolkit with you guys and the path forward. And we're also going to have another section recording concerning GIS data editing in the desktop software. This is just going to be our lecture PowerPoint. All right, so let's talk about what is GIS. GIS is a system. GIS means Geographic Information System. It's a system that works together. The system consists of hardware, so your servers, your PCs, any type of field collection equipment, applications, GPS units, etc. Software. So there are lots of different types of GIS software. I think a lot of you are probably familiar with ESRI software that has been around for a really long time. That's the main software that's used to manage GIS data, whether you're using desktop or you're using Pro or you're using ArcGIS Online. There are many different types of software that Esri produces to help you manage and store your GIS data. Obviously, you have to have the data, and we're going to talk about what are some ways to acquire or create data. So you got to have the hardware, the software, and the data. Most importantly, you have to have the people to make it run. GIS is a highly specialized field. It's kind of a combination of different fields, and the people are critical to the functionality of this. It's about manipulating the data, managing the data, um, analysis and analyzing the data, doing different types of spatial analysis. So all of that has to work together to create the system. So with GIS, you manage data, you can analyze, you have the power of displaying that GIS data in a map form or in an application. That is super powerful because most of us are visual learners. So GIS allows us to ask questions of the data. So because you have the geography part and the information part, you can actually ask questions of either side, right? So you can have a database query to query the information within the database about something, or you can actually do like a spatial query if you want to say, hey, I need to identify all of the homes that are within 50 feet of a pizza place. I don't know, that was a weird example, but you can do spatial query or a database query. So GIS really helps us to answer questions. For example, where is the best location for a new fire station? and or where is the best location for a new park. There's lots of different ways to ask questions of the data, like I said, from either the information side or the geography or the geometry side. So these are all different types of questions that we can ask of the GIS data. So the history of GIS, I think the significance here of this slide is really understanding that GIS emerged as a land management tool. So GIS was developed for land managers basically and planners. So you really saw the emergence of that in the 1980s, and still today in many places you see the GIS management coming out of the planning offices. So this is really significant when you're getting started with data management. Maybe you don't know where to look for data. The planning department is a really good resource because they're probably going to have um, your road center lines, your address points, and maybe your tax assessor office will have access to your land parcels. So I would start there if you guys ever wonder, hey, where do I get my GIS data? Maybe you're starting from scratch and you're not sure where to go. That's a great place to start. So GIS uses geospatial data. When we say spatial, we're talking about data that occupies a space, okay? What we're using in GIS should ideally represent what's going on in the real world. So our road center lines, our structure locations. Ideally, we want those data sets to align with what's going on in the real world. So GIS does use what we call geospatial data. So with that data, we can input, store, we can manipulate. And what I mean by that is, for example, if you downloaded a statewide data set from Oklahoma, maybe you downloaded wetlands or water features or something that's a statewide data set, but you only need a small section of that. You can perform that task using your GIS. You can say, hey, I only want to see the features that are within my county or my city or within this 10-acre tract. So there are a lot of different ways that you can manipulate and work with data in GIS. And you're not just limited to, most of you might be familiar with shape files, but you can also pull in Excel tables, you can pull in different types of databases. So it's really powerful in that way to query and manipulate the data. You can also analyze the data. Like we mentioned earlier, I can identify the best location for a brand new park if I put in certain parameters, like maybe I want to be within a certain distance of other parks. Maybe I want to be within a certain distance of different schools. I need to consider the topography, etc. So there are a lot of different types of analysis that you can perform. I used to do a lot of crime mapping when I worked for the local government where I worked. And one of those things was a man decided that he wanted to blow up his house. So I was tasked with mapping all of the properties that had reported structural damage as a result of that explosion. So that was kind of the situs of where it occurred. And then mapping the data that I received, and the data was in the form of a database, but I tied that to spatial data using the address. I could actually identify the blast pattern of that explosion. And we could also identify some outliers. Um, for example, we plotted everyone that was reported within the building inspections department, but then across the highway, we saw that there was one business that was kind of an outlier. And I think they had determined that maybe that structure, the owners just wanted to put a new roof on or something like that. So there's a lot of power behind analyzing and visualizing the GIS data. So I mentioned earlier that GIS is supposed to model reality. Okay, you want your roads within your GIS to represent your roads in real life. You want your structures, your water features, all of that stuff should be accurate, as accurate as possible to what's really going on in reality. Um, so GIS can really help us identify patterns and relationships and situations. Another type of mapping that I did was vehicle larcenies, and you could always identify, like, in the winter months, because I'm in Virginia and it gets really cold, we get a lot of snow. In the winter months, you would have almost no vehicle larcenies. But then around about April, May, June, July, you can see those larcenies start to increase as the months get warmer. There's no school, everyone's out creating mischief. And you could really see that pattern of vehicle larcenies increase as the temperature increased as well. So that was always kind of interesting. So just identifying different relationships through mapping. I did mention to you earlier that GIS is a system, okay, that's comprised of hardware, software, data, and people. But GIS as a field is really the combination of cartography, which is the study of mapping, statistical and spatial analysis, and database technology. So one of the first kind of real examples that you saw of spatial analysis was back in, I believe it was the 1800s with the cholera epidemic. There were a number of people who were dying in large numbers actually, and there was a doctor, his name was Dr. John Snow, who kind of he did a canvas of the area and went from door to door asking questions about um where people were getting their water, because I think he suspected at the time that people were dying from wherever they were getting their water. And I think overwhelmingly he determined that the water was being obtained from a water pump on Broad Street. And so he took the handle off the pump and the epidemic almost totally stopped. And so that's an historical moment, not only in the field of spatial analysis, which existed long before any types of technology. I mean, this was paper and pen and hitting the streets collecting data. This was not using any type of technology. Not only was it significant for spatial analysis, but also for epidemiology. And so Dr. John Snow is known as the father of modern epidemiology. So GIS is kind of this amalgamation of different fields because we're taking in data from different sources. We're also utilizing the database portion, which is critical because that's the information behind what we're trying to show. And we're also applying different methods of cartography to display our results. And I would love to teach you guys a cartography class. There's a whole world behind how to make maps. I know that paper maps are kind of a dying thing in our existing world, but um, online or virtual cartography and application development is still very much a thing. So it is this amalgamation of these different fields that come together to make GIS what we know and love today. All right, so when we are talking about different types of GIS data, one of the main types is vector data. Vector data can be represented, vector data is used to represent things that have a discrete location. Okay, so you have X, Y, very precise discrete locations like points, lines, and polygons. Okay, so some examples of point data would be address points, well sites for water wells, fire stations, fire hydrants, just to kind of give you some public safety examples. Lines. So think of some data types that can be represented with lines. Obviously, road center lines, railroads, water features like streams or rivers. Okay, water lines, so water storm lines, things of that nature. And then polygons are used to represent areas. So polygons can be used to represent parcels. um, how about city boundaries? How about voting districts or fire districts? So those are some data types that we use to manage for these different types of features. Okay. Now, the thing about vector data and the thing that makes um, a geodatabase so powerful. So let's talk about that for a moment. So generally, I think a lot of you are familiar with a shapefile. A shapefile is a type of legacy data storage. So shapefiles are open source, I guess you could say. They're read by different types of GIS software. Shapefiles can be between 4 and like 7 or 8 different files that comprise a shapefile. A lot of your CAD systems use shapefiles. If your CAD systems consume GIS data, 9 times out of 10, it's looking at a shapefile. Okay. And that's a legacy data format that is used to represent data. Now you're seeing exactly what's on the screen here. That's when you open your shapefile, you're going to see lines, you're going to see points, and you're going to see polygons depending on the type of data that you're looking at. And then you also can see the database. Um, there's also a storage format called a geodatabase, and a geodatabase is the preferred storage format it's actually the required storage format for next generation 911. And with the geodatabase, the shapefile terminology, it's actually called a feature class. So the geodatabase you can think of as like a container that holds different feature classes. Okay. And you have a lot more capability and power when you're managing your data within a geodatabase. One of those things is the ability to create topology rules. Now, topology is a word that we use in GIS that really defines the relationships either between individual address points or individual road center lines or individual polygons, or it can also define the relationship among layers. For example, if I were to say all of my address points should be contained within my county boundary, that is a type of topological relationship. Okay. All of my, if I have a multi PSAP community, all of my PSAPs should be aligned with one another with no gaps or overlaps between the boundaries. That is a type of relationship. All of my road center lines should be snapped where they join um, continuously, right? So every section of my main street road center line should be snapped at the different vertices. So that those are all different types of topological relationships, we call them, that you can establish within a geodatabase. And this becomes super duper important for NG911 because the GIS data is actually making the decision about where the call is routed. Okay. So we can establish topology rules by using a geodatabase. It doesn't mean that shape files are not important. Some of your systems, like some of your CAD systems or even your 911 system, may always consume a shape file. It's easy to export a feature class into a shapefile. So they are still relevant, they are still significant, but for building NG911 data, for managing those relationships in topologies that are required for NG911, the geodatabase is required, okay? The next type of data format is called a raster data format, and this represents continuous data, okay? These are things like satellite images, aerial images, digital elevation models, which some of you may not be as familiar with those. You might be familiar with the imagery that we're showing here, but those are raster data sets. And you can actually obtain what would be called planimetric data from certain types of aerial imagery, like the image to the far left here. We can see that there are roads in this picture. We have sidewalks, we have building footprints, or we have buildings that are shown. And what we could do is actually digitize, and that's another word that you're learning today. So to digitize means to draw a line or a point or a polygon over top of the feature that you're seeing in your aerial image. Okay, that's called planimetric data. The digitizing is the act of the drawing in the GIS software. Okay, but you can acquire planimetric data from aerial images. Some people actually pay for this. I'm working with a county in Alabama that actually pays a company that's flying their aerial imagery to get these planimetrics every time they fly. So they've always got an update of building footprints or road center lines, etc. So if you don't have road center lines, but you get imagery from somewhere, you can go through and start from scratch and create your own road center lines. So that's raster data. That's continuous data. That's basically a matrix of cells. Now, we've just talked to you about the geometric attributes or the geometric um, qualities, I guess you could say, the geometry, the geography part of things. But now I need to talk to you about the attributes. The attributes is the information, right, behind the geometry. So basically every single think about your favorite person or your pet. Think about their qualities, okay? You have a friend who has brown hair. they have glasses, they have blue eyes, they are 6 feet tall. Those are all attributes. They're descriptions about a person, place, or thing. That is what an attribute is. It describes something. And just like we can describe people, places, things, pets, using attributes, we can also do this in the GIS data, and we should and we have to do this for NG911. Think about when you see a paper map, or when you look at a paper map, you see those lines, right, for road center lines. You might be able to discern from the map the classification of the road based on how it's symbolized, or you're looking at the map key or the legend, etc., and it's saying, oh, well, a thicker red line means that it's a highway, a thinner black line means that it's just a major road. So there's different ways to classify data on a paper map. But when you bring this into a GIS environment, you have so much more information and you have so much more power. But you have to give and associate the information. You have to provide the attributes about that particular road. If I draw in a road center line for Green Street, I need to be able to provide the prefix, the suffix, any directionals that are associated with that road center line. I also need to provide the road range. I need to provide any community information. There's a lot of information that you're not going to necessarily get when you look at a paper map. So attributes are very powerful in this way. Like I mentioned earlier, we can ask questions of the data, not only on the map side, which is just the picture part, but also on the database side. So attributes are stored in a database. And the database, it looks very similar to an Excel spreadsheet, right? You have rows, you have columns. The columns we actually call fields, and the rows we call records. And the record is associated with each individual feature. So, for example, if I have 15 segments of Main Street, that's 15 different features stored within that attribute table. Okay. So attributes are critical to the GIS data because they provide the information about the feature that we're looking at. Yes, it is nice to have the picture of the points or the picture of the road center lines, but when you have the information, it's so much more powerful and you can do so much more with it. So let's talk about ways to create GIS data. So you can create GIS data from databases. If you have a lat long, you can plot those and create actual points from lat long coordinates. Okay. We can also use digitized maps. Digitizing is when you bring those maps into that GIS environment. So a lot of people, they have old legacy maps, historic imagery that they can pull into their GIS, and they can digitize features from that. That's a different way of collecting data. You can also go out in the field. GPS field collection is huge. I work with some clients who use GPS field collection as part of their address assignment process. When they receive a building permit or a request for an address, they'll go out, they'll physically collect the driveway location or the structure location, and they get a very precise, accurate location that way by using GPS. I used to use GPS to do crime mapping. So often you will have investigators that use measuring wheels or other types of equipment, and it takes a really long time for them to be outside using those tools to measure. But with GPS field collection, especially if you have something that's super accurate, the one I had was like sub-decimeter accuracy. You can go out and within seconds, you can collect the point, provide the attribute, right? So if I go out in the street and I collect a clip, I can put that in my attribute table right there in the field and then bring it into my environment in my office and go ahead and map it. It's super fast, it's super efficient, and it saves a lot of time. Another way that you can create GIS data is just like what we talked about earlier with aerial photography, also remote sensing. But aerial photography, especially, has been invaluable to local governments because they can obtain a lot of information from that aerial photo. So if you look at this black and white image on the right, you can see that we've got several pieces of information. We've got road center lines, we have ball fields, we have parking lots, we have building footprints. There's a lot of data that we can get just from this aerial imagery. So this is, and again, I mean, this is something that takes a tremendous amount of effort, which is why a lot of people, this is how their GIS data actually started. A lot of this was way before they had GPS units. And so once there was an aerial image obtained, either a company would go ahead and digitize that from the aerial image, or the agency would bring that back into their GIS environment in their office, and they would just start collecting the data. You can also get curb and gutter. There's water features that you can identify, and that's why it's really valuable to use leaf off imagery. When you're looking at Google, that's leaf on, so everything's really green and fluffy and pretty. It's a pretty picture. But the real high quality functional imagery is always leaf off, because that allows you to see things like water features very clearly, allows you to see the corners of buildings. So I would highly recommend, if you're looking at aerial photography, that you plan your flights, and typically flights are planned through the fall and winter months. All right. Coordinate systems. Coordinate systems are one of the most boring topics of GIS. Okay. It's right up there with metadata, which, we'll talk a little
Yeah,
bit about
don't
that
fall
later.
asleep.
Yeah, don't fall
Don't
asleep,
skip
wake
this
up.
section either.
Now's the time to get some coffee.
Yeah.
But the
Yes.
coordinate systems are super, super important, not only for overall GIS data management, but also for NG911. All of the data has to be managed in the same coordinate system for NG911. And let me explain why. It's so when my PSAP fails, where I live in Virginia, that one of your PSAPs in Oklahoma can route my calls. NG911 is about a network of networks. It's not just about your city or your state. It's about an entire nationwide system where all the data is seamlessly put together. And the way that that is accomplished is through coordinate systems. Okay. So there's two main types of coordinate systems. There's a geographic, and then there's a projected. Okay. Anytime that we are taking something round like the earth and making it flat, as for a piece of paper or on a computer screen, there is going to be some distortion. Okay, so there are different types of projected coordinate systems. Most of you locally are probably using state plane NAD 83. Okay, and for me, it's Virginia North because I'm in the northern part of Virginia. So there are lots of different projected, you may be using UTM, there's a lot of different coordinate systems. And you can and should continue to use these at the local level for all of your business needs, right? I think that UTM or state plane makes it easier to seamlessly piece together with your neighbors. So if you have neighboring counties, or at a regional level, you can bring that data together. But when you're talking about nationwide, it has to be a little bit different. Okay. So if you can envision the earth like we're cutting it like sections of an orange, you're going to have to flatten that out. Okay. So there are different ways of accomplishing this. With the geographic coordinate system, we are defining a location based on latitude, longitude. And with a projected, this is what's used to make maps. Okay, so for example, a long time ago, when you had people that were exploring the world and sailing to these different places, they had old coordinate systems that were used, and really depending on what you were doing, you would use a different coordinate system because some were more appropriate than others for, say, modeling coastlines. You really wanted, if you were a sailor, you really wanted something that was super detailed so that you could be fully aware of what you were doing when you were coming in to explore an area. So there's lots of different coordinate systems for projected, and the one that we use for NG911 is the NAD 80, or I'm sorry, is WGS 84 geographic. Okay. So the WGS 84 is what you are going to be required to um, project your data into for NG911. And that's not just for your county, that's not just for the state of Oklahoma, but that is nationwide. So the good thing about the toolkit that we're going to talk about is that the toolkit actually builds a geodatabase that already has that coordinate system applied. So there's very little lifting that you have to do on your end. to get that to happen. So you can still continue managing your data in your local and just switch to WGS 84 when you are building your NG911 compliant geodatabase to submit to the state. All right, so I almost asked if there were any questions, but Becca, do you have any questions?
Not at this time.
Okay. All right. If you guys have any questions, then just feel free to reach out to us.
I would say
Um,
throw it in the chat, but that also
yeah,
wouldn't work because we don't
yeah, that
have
would not work.
we're
We
so used to
are,
doing this with people.
I know, we're used to having people and now we're just kind of talking to each other, which is a little awkward.
Yeah,
So
it's
anyway,
fine.
if you have questions, email us and we will get back to you about whatever your questions are. So let's talk about the GIS data model. What is a data model? So a data model is really a definition of what is required of GIS data and that associated data management to accomplish a specific business need or a goal. Okay, so in this circumstance, we're talking about NG911. All right, so the state data model defines the layers that are required. So, for example, road center lines, address points, PSAP boundary, discrepancy agency boundary, ESBs for fire law and EMS, ESZs. Those are all layers that are defined and required by the state's GIS data model to make NG911 function. Now, the important thing is that Oklahoma's local data model actually is built off of the national model that you can reference that's published by NENA, which is the National Emergency Number Association. They have a national model, which a lot of states and a lot of locals follow the national model, but there are many states, such as Oklahoma, that have a state model. The state model actually exceeds the national model because it has additional fields that are required. So, additional information that's required. For example, storm shelters, that is information that is included within the state's model that is not included within the national model. And what the model does is it actually and not only describes and defines what the layers are that are required, but it also tells you how they should be represented. For example, addresses have to be a point feature class. We already talked about that earlier, that addresses are best represented by points. Now, it doesn't mean that you still can't have building footprints with addresses associated with it, but for the purpose of NG911, to make that work, those have to be in a point form. Okay. The data model also defines the attributes of each layer. So, for example, in my address points, I have a number field, I've got all of my street fields, etc. There are different attributes that are required of each different type of feature. That is also defined in the data model. There are relationships that are defined within the model. So remember earlier we talked about the idea of topology as far as the relationships between each feature. So my road center line segments have to snap together. My all of my address points must be contained within my county boundary. My state boundary must totally encompass my county boundaries, etc. Those are different types of relationships and topologies that are defined within the data model. So the Oklahoma Geographic Information NG911 and addressing standard can actually be found on the website, and I highly, highly, highly recommend that you all become very familiar with this because this is really going to help you with understanding how the data has to be managed, what types of information is included with each feature class, the types of attributes that are required. All of that is defined within this standard. And the way that you get to this is you would go to the ok.gov/911. So this is the Oklahoma 911 Management Authority website. Go to programs, statewide NG911 training. And this is where we've got all of our classes. So the state has um, a great YouTube channel that you can click on here, and these are all of the different classes that we offer. Now, we have, the toolkit training, we have a couple sessions coming up next year. We've done several of those already. We also have the Intro to ArcGIS class coming up next year. We also have classes coming up next year for addresses and boundaries. So if you click the GIS toolkit, and the reason why I'm telling you to click the GIS toolkit is because the toolkit is the front end basically for the state standard. Okay, that's where you're going to be actively working to get your GIS data ready for NG911, but you should be familiar with the standard. So the NG911 and address standard document is super important. This is gonna have everything that you need to understand what is actually happening. So there's some really good information in the beginning about the work group, about the management authority. And if you scroll down, scroll down, scroll down, probably making you guys sick, and I apologize, but this is really the meat and potatoes of the document. Okay. So what this is basically defining what the attribute table is supposed to look like for each feature within your GIS data. So this is saying that your addresses have to be a point. For the address point feature class, they have to be represented as a point. So these are all of what we would call field names. So field names you can think of like columns in an Excel document. It's defining or describing rather what these actually are. It's telling you what the field type is. Now the type is, it means what kind of data can I store within that field? If it's alphanumeric, you might also know that as a text field or as a string field. It means that it can store numbers, letters, and different types of symbols. Okay, so that's alphanumeric. And then the width of that field. So how many characters can I have? How many characters can I have in that field? And the priority here is really important because the priority is defining whether that field is mandatory, conditional, or optional. Okay. Mandatory means you have to have it in the data. That's what mandatory means. Conditional means that if it exists in the data already, then you should populate it. Okay. And then optional means it's optional. So mandatory, conditional, or optional really defines, hey, do I have to manage this in this data or not? Now, remember, we want to do more than the bare minimum for our first responders and for our call takers and dispatchers. We want to pack the record for them. Okay. So I would highly encourage you to flesh this out as much as you possibly can with accurate and complete information. That is 100% critical to NG911. So if you have a lot of apartments in your community, a lot of sub-addressing situations like commercial buildings or different types of, mobile home parks, etc. Try to get to that level of detail where you're putting in the unit number and the floor if it applies. Okay. A domain table. What is a domain? Well, a domain is basically a parameter that you can set on a field so that you can have a pick list or pre-populated values from which you can choose as you're moving through your data management. Okay. So for example, for your street type, this is going to be really useful because in next generation 911, you have to start spelling out things like street, STREET, avenue, circle, boulevard. Those have to be fully spelled out in order for next generation 911 to work. And the reason for this is because of the language or the protocol that's used during the 911 call. Okay, it relies on those fully spelled out and standardized values. So if you are currently storing all of your data in one field, if you have a field called address and it's, 123 North Main Street, apartment 7, going forward, you're going to have to separate that out into individual fields. We call that parsing in our world. Parsing means that you're taking each piece of an address and you are putting it into its appropriate field. Okay. So the domain tables can really assist you with managing that data. So you don't have fat finger situations where you're trying to type in boulevard and you can't remember how to spell it. It provides you a pick list. Okay. And if there is a domain associated with a particular field name, it says that right here. And if you scroll all the way to the end of the document, you can actually see the domain tables that are associated. Okay. So these are the different domain tables.
And this is super helpful, and I know you mentioned this, but the toolkit will build this for you and
Hmm.
apply these domains to all the appropriate fields. But I am a big fan of domains, especially when it comes to data quality. And you have control over the values and the way they are formatted and the way they are spelled. Um, as somebody who works in data all day, every day, working with multiple other staff, knowing that there's a designated list of values that's being applied to a field automatically is going to produce higher quality work, right? So, um, yes, like Annie's saying, get familiar with these domains and really, understand the power of even creating other domains in your other fields to help eliminate human error.
Absolutely. That's an excellent point. Because remember that we have to have accurate and complete GIS data for NG911 to work. And the more we can standardize that data, the more we can put into domains, especially when you think about bigger environments where you may have multiple data editors, this becomes super important.
Mhm. Absolutely.
Especially, yeah, for database management, a lot of folks don't understand how to properly manage databases, and it's caused some real issues in people's data. So really try to get familiar with this and understand what that means for your data. The other cool thing, Becca, that I didn't show them is that when you go out to the toolkit page, there is an NG911 address standard schema.
Mhm.
So this is like, so the schema and the document are directly correlated. So if I open the standard schema, this actually is an Excel spreadsheet. It's opening on my other screen. I'll move it over here in a sec. So what this is it actually is a schema, and you can see it looks almost identical, right, to the model that we just looked at. The cool thing about this is that you can, and you really should, before you proceed with any type of NG911 effort, because many of you are maintaining data sets that you're using for other business needs as well, like permitting, for example. What I would do, and what you really should be doing anyway, is you should be doing a data inventory, because how many of you guys out there have old data that's just sitting around, junk files that are not being used anymore? What are the authoritative data sets? And what you should do is really a data inventory every year. You should figure out what the data sets are that are authoritative, who's the manager, who's editing them or contributing information, and what are the fields that are being maintained. And what you can do here is kind of like your own self field mapping. And we'll talk about this a little bit more in the toolkit class, but I don't want to dive too deep into this. But I highly recommend that you download this Excel, because what you could do is you could come in here and actually insert your own field name, and maybe you have, maybe this field is called full name in the state data model, but you call it street name, right? So you could add another column in here and say, okay, well, they're calling it full name in their model, but I have it as street name. And the significance there is because when you go to get your data ready for NG911, you're going to be pulling the information from your data that meets this standard. So for example, I know that when I go through the field mapping effort for my address points, where they're calling it full name, I'm just going to select street name. And so it's going to pull that because that value is appropriate for the full name value. So I know that was a little bit confusing. It'll make a lot more sense when you see the toolkit. But basically, if you can envision a line of containers, we're basically we're basically saying this data fits into this container, even if it has a different name, right? This field, we're calling it one name, but it fits in here, even though someone else has another name for it. That's basically what
Mm.
field mapping is. Field mapping is incredibly important to NG911, but this makes it so much easier. If you download this spreadsheet, you can actually do kind of like your own field mapping on your own before you actually get into the toolkit, which is really
Mhm.
important because the toolkit field mapping is a little bit cumbersome, and having it all done out ahead of time, whether it's on a sheet of paper or in a notebook, this will help you tremendously. So I think this is really
Yes.
important, and I hope that you guys will employ this before you go into the actual toolkit field mapping portion. And it's good to use for
And
your data inventory too.
absolutely, and I was gonna add on to that, Annie, if you wouldn't mind jumping back to that, or this is perfect right here. We y I I consider myself a paranoid GIS person, and what I mean by that is I always like to document every stage of where my data is at, and then if I'm going into a different phase of a project, or if I'm converting the schema, right? If I'm changing the structure of my data, I always want to have, like you said, an inventory or documentation of if I ever need to jump back a step, I know how to translate my data back. So we do this exercise all the time on our team where we do field mappings because we never want to misinterpret your local data, but it's your way of just backtracking and having some sort of documentation on where did I start and where do I need to go, right?
Right.
So definitely wanted to reiterate the importance, like you said, Annie, of field mapping. And then I have two other items I want to touch on with this specific the schema here. I'll give you a sneak peek into the toolkit class that we teach, but going back to the domains, if you have a field in the standard, so I'll just use the suffdir, for example, the suffix direction, you can see that the domain table has the direction domain applied. If you do not have the proper domain values applied in that field and you go to validate your data using the toolkit, it will flag an error. So just keeping in mind that if you're going to have domains well, they're required in the actual Oklahoma standard structure. So if those domains are present in a field, they must be applied appropriately, or they're going to flag an error, which prevents upload to the repository. So just wanted to be clear on that. You must use the domains properly. And then the other thing I want to jump back to is the priority here, the mandatory, conditional, and optional. Um, you explained it really well, Annie, but I want to drive it home because this is something that it took me a long time to wrap my head around. Mandatory, like Annie said, is a required field. So you have to have it in your data and it has to be populated. And that means it must be completely populated. Every record in your data has to have the appropriate value, meaning no nulls are allowed, nothing missing, right? And then conditional is sometimes, I mean, it's conditional, but I always think of it's like a watered down mandatory in my mind
Hmm.
because if it's like Annie said, if it's present in your data, it must be maintained. So a good example of that is a street that has a pre-directional. So if I have North Main Street, North is considered in my mind mandatory because it's present in the data. So it needs to be maintained in the pre-directional field. But not every street has a pre-directional, right? So if it's present in the data, it must be maintained in the designated field. That's what conditional means. And I see you jump down to the legacy
Hmm.
fields down here. Um, those are definitely values that, yes, they're conditional in the standard, but in my mind, they're essentially mandatory where we are right now in this phase of NG911 because those legacy fields are what keep the connection and the communication to your existing legacy systems, right? Um,
Yeah, and they're also important for synchronizing your road center line data to your MSAG data as well.
mhm. Yep.
Because you're still going to be using your MSAGs for a long time. They're not just going to go away right now. So you still want to make sure that both data sets are answering the same questions. And it's very important to include. And by the way, the toolkit, I think at the next release of the standard, those MSAG tools are going to be functional. So those are going to help you improve the quality of your MSAG. We have not been able to teach those to this point because there are some updates that are required. But I think after the next update, you guys will have access to those MSAG tools. So again, really important to keep the MSAG where it needs to be, so that you can synchronize those two data sets. And by the way, speaking of mandatory, conditional, and optional, since we're looking at the schema for the address points, I always like to point out the fact that address is a numeric field, so only an integer is going to be accepted. So if you have 101B, you can't put anything else but a 101 in this field. You have to move that B to one of these different fields. But the fact that you have an address, it's conditional. So I think that really throws a lot of people because everybody thinks that an address is an address like we would traditionally know of one. So 101 North Main Street, 102 Clark Street, etc. But in NG 911, there are other ways of defining a location, not just by an address. Okay, so let's look at some of those other fields. So for example, you have lat long. Lat long is in here. Now, this is an optional field, okay, but if you didn't have an actual number for an address, you could drop in the lat long here to define a location. You've also got landmark name. You've also got the additional location field. There's lots of different ways to define location using this data model. So it really does require us to take a deeper look, a little bit more thoughtful consideration about how we're managing our data, because for some things you can't give it a numerical address for whatever reason. Maybe you can't get to it from any type of street. Maybe it's not that type of geography. So you have to come up with other ways of doing this. And the model allows for that milepost, for example. Those are all different ways that you can manage that information without giving it a specific structure number. Okay. So I hope that helps clear up what the purpose of the standard is, but there's a lot of really good information before you actually get into the schema. What we call is, there's a lot of really good information before you get into that stuff. So anyway, we've talked about the attributes, the spatial representation, and then we've gone over the domain. So that was a lot of information that we just threw at you guys. So the purpose of the standard is to develop and maintain the data that's required for NG 911. I want to be very clear here, and I think it's going to be reiterated and over and over and over again. Every class we have, it's really important to manage the data and continually validate the data time and time again. This is not a one and done type of thing. Getting the data standardized, getting it into the appropriate fields, parsing it out, applying the domains, that's just one part of that data management. If you're assigning a lot of addresses, if you're drawing in a lot of roads, if you're annexing, there are lots of workflows that need to be put in place to make sure that that is appropriately reflected in your GIS data. Okay, so we'll talk about that here in a little bit. So who should use the standard? Basically everyone. I mean, that's that's pretty much the long and short of it. Anyone who's managing that GIS data for NG 911, whether you're a cog, you're a PSAP, a vendor, everyone has to everyone has to manage that data to the standard before it is able to be accepted into the repository. Okay. So everyone has to be able to use this and follow it, and the data has to adhere to it. Okay. Let's talk about NG911 and GIS data quality. So we've already talked about briefly the required layers. So address points, road center lines, the PSAP, public safety answering point boundary, the individual service boundaries for fire, law, and EMS, and the provisioning boundary, which is known in Oklahoma as the discrepancy agency boundary. That's kind of a funny term. So let's talk about a discrepancy agency boundary. What does that mean? A discrepancy agency is the agency that is responsible for sending and receiving information to the next gen core services provider. So, for example, if I'm the data manager of my county, I can provision or provide my data, all of my GIS data for NG911 to my core services provider. So the core services provider is also going to run checks and balances on that GIS data. It's going to run its own set of validations, whether it's AT&T, Motorola, whoever is doing the core services, they've got their own validations that they're going to need to look at, okay, and apply against the data. So once the data is run through those validations, that data is provided back. Any anomalies that are generated from that run, that validation run, are going to be provided back to whoever the discrepancy agency is. The discrepancy agency is who's responsible for handling discrepancies. Those validations that are run on the core services side identify discrepancies. That's why there is such a thing as a discrepancy agency. Now, as a PSAP, you might be your own discrepancy agency because you've got your own GIS people, et cetera. But if you're a smaller town that's located or situated within a bigger county, maybe you have, maybe you're managing some data, but you don't want to take that on of being that discrepancy agency for your own locality. You can actually have a different discrepancy agency ID. And when I talk about that, I'm really talking about let's see, I don't know if I closed it or not. No, here it is. So here's the discrepancy agency. See the agency that receives the discrepancy report, and here's the agency. So everybody is going to have an agency ID. But for some of you, your agency ID and your discrepancy agency ID might be different. Okay, if I'm providing my data to someone else to submit on my behalf, then my discrepancy agency ID is going to be different. I know that's a little bit confusing, but if you're managing and editing and provisioning your own data, then your agency ID and the discrepancy agency ID are going to be the same. If you are managing GIS data, but you're not provisioning that into your core services provider, then your discrepancy agency ID is going to be whoever's doing that for you. Okay. So the other thing I want to notice or note here is that the provisioning boundary and the PSAT boundary are both managed by the state. The state manages both of those feature classes for you. Now, if there needs to be a change, there is a process for that. So I think you have to get together with your neighbors. There has to be a decision that's made. You have to sign a letter, and then that has to be submitted to the state. So there is a process that you need to go through. Now, what are some reasons why you might change a PSAP boundary? Well, what if there's an annexation? What if you are a city that's a PSAP and you're annexing, 10 acres from your county in which you're located? You're going to have to adjust your PSAP boundary to reflect that. So that is one example of a PSAP change. Another example might be maybe you guys decide that, maybe there's a subdivision that's physically located in one county, but it's always the other county who responds. Now, response and call answering are two different things. Okay, but maybe the calls get transferred back and forth, back and forth. One of the goals of NG911 is to minimize transfers. Okay. So if it's determined that Well, we should adjust the PSAP boundary for our county to encompass a subdivision that's technically outside of our county. That would be another example of changing that PSAP boundary. So the PSAP boundary is actually the boundary for who gets the call. It's not about who responds to the call, it's about who gets it. Okay. So that's very important because in next generation 911, calls are going to either be routed based on the geospatial location, okay, your civic locations or geospatial location. So your civic locations would be landlines coming from actual structures, or it could be from a mobile device, which of course over 80% of our emergency calls come in from mobile devices. But so anyway, that's just kind of like two examples of how and why you would change a PSAP boundary, but there is a process defined for that, and we are going to talk about that when we come to do our boundary class next year. All right, so for road center lines, you want to make sure that you are vertex or I guess not really edge matching, but you're matching at each vertices. So where you have different sections of like Constitution Drive, for example, you'll want to make sure that each one of those segments snaps to the one that adjoins it. Okay, you also want to make sure that the roads are split at different boundaries. So we especially say like municipalities or any place that you have a geometry or attribute change rather. So wherever your attributes would change, like for your community value, you'll want to make sure that you split your road center line there as well. And you also want to make sure that you don't have overshoots or undershoots, duplicate center line geometry, because that can all cause issues with routing. So address points are required. So when a 911 call comes in from a civic location, it's going to look for the address point first. And if it doesn't find it, then it's going to go to the road center line range. So address points are very important, not just for call routing, but also for resource routing. So a document that I highly encourage you guys to check out is the SSAP, which is the site structure address point document from Nina. And if you give me one moment, I can actually pull that up. And it's not a standard. It is an informational document. That's very important to understand with the NINA documents. You need to have a good understanding of what is a standard versus what is information. And you'll know because it says INF, NINA INF. So this document is really valuable for determining how to represent different types of structures in your address points, whether that's using driveway placement, structure placement, am I using stacked addresses? And as you can see, this is a very large document at 62 pages. So there's a lot of really good information in here about how to accomplish that. Okay, and I highly recommend, and there's a lot of really good graphics in here as well. So see, you can see different graphics, a lot of really good examples. If you're not sure about how to place address points, this can be very helpful. But again, it's just an informational document. Okay, it's not telling you this is how it has to be. Okay, and they do that for a reason because so many people are in various states of readiness when it comes to their GIS data. And I think on the national level, they recognize that something is better than nothing, and they don't want to let perfection be the enemy of the good. Okay, so I think the idea is that it's always good to start from somewhere and then work toward a goal of different types of accuracy and precision. For some people, they have to maintain their addresses on the driveway, and that's for their AVL. Some people have to maintain on the parcel centroid because that's what's generated from their permitting system. Some people don't even maintain address points. They're relying on it to be passively generated out of another software system. So these are all things to be aware of. This is what I'm telling you when you need to look at your data inventory. What is it? Who's editing it? Who's managing it? Where is the origin? Where does it come from? Do you have an address points data set that's generated nightly? Because that's going to significantly impact how you're managing data going forward. Okay. Structure placement, I will tell you, is the best and most accurate for next generation 911. It is also the most precise, which is really important, especially for bigger parcels. Like if you have more rural areas, you've got multiple entrances into a property, you've got farm lanes, you've got gravel paths. There are lots of different types of entrances that might not be appropriate to put your address point on because it's implying, hey, if my address point is here, then I can enter the property through this way. We do recommend that you guys develop access points, and that's something that we also do for people is we develop that access point layer, and that not only defines the actual structure or the entrance to the property, but you can also include information in there like gate codes, etc. So sub-addressing is optional in the model, but I will tell you that it's extremely important to have sub-addressing in that data because sub-addressing can be very confusing to first responders, especially like where I live. My city is like almost 300 years old and we have a lot of mixed use buildings. So you may have like a restaurant and a dry cleaner downstairs, but upstairs you've got, 3 or 4 apartments. So it's really important that you have that information represented in your GIS data. It's not always intuitive to a first responder that when they come up on a property, what exactly is gonna be there. Okay, so having that data represented is very, very important. Okay, college campuses, really big. Make sure that you have each of those buildings uniquely addressed. And again, we're going to talk about this in our addressing class that we're teaching next year. But it's very important that you get as granular as possible. Now, the model does allow addressing down to the seat. I don't recommend that if you value your sanity. I think that's extremely ambitious um, and resource intensive, I should say. Especially when you're thinking about like what happened during COVID, where people had to make space, right? We had to create space and move things around and things like that. So doing addressing to the seat level is not realistic, I don't think. But if you can get to the floor, you can get down to the subunit, I think that's perfect. That gives a great picture for our first responders, especially since like intuitively, depending on how the sub-addressing is done, sometimes your ABCs, 1, 2, 3s, 101, 105, whatever, doesn't always align with the expected sub-addressing schema, I guess you could say. So in other words, you may have a 101 that's actually on the 3rd floor. So that's what I'm talking about. So making sure that you include as much information as possible to help with that. So there are different ways to place address points, and that document that I showed you just a few minutes ago, the SSAP informational document, further defines these. But I think the most common would be parcel addressing. That's where you find a point within a parcel centroid. Structure addressing is very common where you've got the address point placed on top of the structure. Some people will do structure, but actually place it close to the front door, which is really nice because that indicates the main entrance to the building. And some people will also place at the access way of the property. So again, that's more beneficial for AVL to help the vehicles identify where they need to go. All right, so PSAT boundary, the PSAT boundary is incredibly important. The PSAT boundary is responsible for routing the call. The PSAT boundary determines who gets the call. So before anybody ever answers the phone, it has to access this data. The call has to access this data before it can ever be answered. So I want you guys to think about that. Think about what a shift that is from how things work currently in 911. The GIS data is making a decision. So if you're a GIS person and you're managing data for NG 911, I am calling you a geospatial first responder because your data is essentially on the scene before anybody else is. So I want you to think about the gravity that that has and how important that is. Now, like I said, for a while, the MSAG and ALI are going to be used to kind of bounce back if the geospatial call routing fails, depending on the NGCS provider. But you guys need to be very aware that this data has to be accurate, complete. You need this to be tight. It has to be correct. That's why I never recommend that you guys just take a data set that the state gives you and just roll with it. I would not do that. You really need to review the boundaries with your neighbors because nobody knows your community like you do. Nobody's going to be able to the state doesn't know the individual nooks and crannies of your county boundary and like where your subdivisions extend, beyond the county boundary, but they're really located physically in another county, etc. They don't know that. Okay. So you guys need to sit together and review this data so that you can determine, yes, in reality, this is where the calls actually should come in. We have high volumes of call transfers in a specific area, so we need to adjust the boundary in this particular area. Okay. And we see stuff like this all the time where you've got, in this particular example, a structure that sits in a gap. Okay. A gap is where you have basically an open space between two PSAP boundaries. What that implies, what that's telling the call routing is that this is a no man's land. There's no call coming in from this. There's nowhere to route this call based on where it's coming in because the call's not hitting a PSAP boundary. And we see this with single structures. We see this with entire subdivisions or, half of cities. All right. So this is something that you guys really need to be diligent about when you're doing this because a gap implies that there's no coverage at all. So the call's not going to be routed. An overlap says, well, I'm going to go to default routing. And so then you're basically letting the machine make the decision for you. Okay? So your individual service boundaries are your police, fire, and EMS or law, fire, and EMS. It really just depends on which standard you're looking at. Um, but your ESBs basically define the service area for that particular boundary. You also, in the state of Oklahoma model, you have to have an ESZ layer as well, because ESZ layers are still very relevant for your CAD systems. So you're going to have to maintain both. But again, you don't want to have gaps, overlaps, or duplicates. And in the toolkit, if your boundary is not fully encompassed within your PSAT boundary, that's going to throw an error in the toolkit. Okay, so you will have spatial data checks that occur on those data sets as well. So everything works together. Don't just think this is about, oh, I have all of my layers. No, it's looking at the layers themselves, the attributes within those layers, and then also how they spatially relate to one another. Okay, it's a holistic look at the entire maintenance of that data set. All right. So when we talk about accuracy and completeness, okay, accuracy means, do I represent everything in my data that's actually going on in the real world? If a new I don't know, in my area it's roundabouts are big, right? Because roundabouts improve traffic flow and also reduce expenses with managing red lights, etc. So if a new roundabout goes in, is that reflected in my data? And how quickly can I get that in? Because that's important. First responders need to know, hey, I'm coming up on a roundabout, right? So, do my road center lines really reflect what's going on? Do you have a workflow in place? That's probably the biggest part of this. And that's kind of where I live is in the workflow because data tells a story, and if you guys have stuff that's going on in your community that's not being reflected in your GIS data, that's a workflow issue. That's not a data issue because the workflows directly contribute to what's going on in the data. So if you're missing things from your data, that all goes back to workflow. Why is it missing? Well, I didn't get the paperwork I needed or the plans I needed from this department. That's all workflow stuff. So that's something that has to be worked out if you want solid NG911 GIS data. Okay. So is what's going on in the real world, what's happening in my data. Okay. Now, completeness, we just kind of talked about it. You can kind of think of a checklist, right? I'm going to write out all of my data layers. I have address points. I have road center lines. I have PSAP. Check, check, check. Okay. I have the layers, they exist. Okay. But what's going on within that data? Am I missing data from any of those layers? For example, Am I missing address points? Two of the most mismanaged parts of addressing are sub-addressing, right? Representing those mobile home parks, those industrial buildings, the strip malls, the apartments and condos. That stuff is missing all the time. And then also municipality addressing. So if you are a county that's got a self-addressing municipality, what does that look like in your data? Are they sending that to you? Again, that goes back to workflow. Are they assigning addresses and communicating that to you? That's a workflow issue. But that workflow is ultimately going to impact the end state of what that data looks like. Okay, so am I missing data? Am I missing address points? Do I have all of the fields present in the data? When I say, do I have all the fields, do I have all of these guys? I've got to have all of these things within my data. I talked to someone the other day. They said, look, I'm seeing all these fields. We only have 8 fields in our data. So that person has a lot of work to do on their data to get it compliant. Okay. So do I have all my fields? And then beyond that, are the fields populated? Right? So it's kind of like a telescoping effect. You have to kind of like go from the really broad checklist of, hey, do I have all my layers? And then you just kind of have to start drilling down, because just because you have all the fields doesn't mean that your data is ready. Okay? Those fields have to be populated with accurate information. That's incredibly important. All right, so I've shown you the standard a couple times, but the toolkit is really what I call kind of like the front end for that standard. Okay. So the state of Oklahoma has designed this toolkit. This is designed by the folks from ODOT. And the state really, the goal here is an easy way to get your GIS data ready for NG911. Okay. Now, the toolkit actually uses ArcGIS Desktop, or ArcMap as you might know it, not Pro. Okay, so that's why we're teaching this intro to GIS class, not only to get you introduced to the concepts, but also to to this software. This is actually really old software. It's been around for a long time, and I know that a lot of you have already made the transition to Pro, but the toolkit operates in desktop. That's very important. Okay. So what this does is it actually builds a compliant geodatabase. What does that mean? It means it's building a geodatabase, a container that is equipped with the framework to build those NG911 compliant layers. Now, two of them have already been taken care of for you. That would be the PSAP and the discrepancy agency boundary. Those are already managed by the state. Hopefully, most of you already have some of the layers. But if you don't, there are tools in there to help you create them. Okay, but it builds the container for the data. It builds that container with that WGS 84 coordinate system that we talked about earlier. Okay, it already does that for you. You don't have to go through the process of creating a new or reprojecting data. You don't have to do that. The toolkit builds that for you. Okay. It also applies the domains. So what it's saying is, yeah, we're going to build this container. We're going to get it ready by applying the appropriate coordinate system. And then we anticipate these different fields that are coming in for these different data layers. So we are going to go ahead and get those domains set up for you. Okay. And we will show you more of that in the toolkit class, which is coming up next year. But I wanted to kind of let you guys know and just give you kind of a foreshadowing of what the toolkit actually does. So it builds that geodatabase. It contains a lot of different what we call field mapping tools in that prep. So remember when I told you earlier that you might call something street name, but in the field in the model might say road name or something like that. It actually gives you that field mapping process, which is why I strongly encourage you guys to go back through this effort and field map your data out to say, okay, I call it road name, they call it full name. So you know what container to drop your name in so that you don't need to recreate that data. Okay. There are also some adjustment tools that help really with standardization and QC. And then there are some different tools that help you identify potential anomalies, right? So address range overlaps, Fishbone tool, which is a visual geocode of that address point to the associated road center line. So there's a lot of really good tools in here, and I really hope that you guys will come to this class. I strongly encourage you because this is not a wizard. This is not this is not intuitive, okay? I strongly encourage you guys to become very familiar with desktop before going into this class because the toolkit class is very advanced, and I want you guys to have a base understanding of GIS and how to operate and function within the software so that you can be comfortable managing data within the toolkit. All right, so let's talk about implications of GIS data management for NG911. Okay, so we want to make sure that our GIS data can support the caller's location first and foremost. That's why our PSAT boundaries are absolutely critical. Okay, so the completeness of that data, having complete address points, you know, I can't even tell you how many times I've talked to people that have huge holes in their data for various reasons. Or, their workflow mandates that, they assign the primaries, but they're giving the power of sub-addressing to landlords or developers. So again, that all goes back to workflow. Okay, but can my data support the caller's location? That's a very critical question to ask for NG911. Can my GIS data support the queries for routing the call? So making sure that your PSAT boundaries do not have gaps and overlaps. Okay. What does a gap mean? A gap means that your call's not going to be routed. An overlap means that the machine is going to make the decision about whether or not to default route. Okay. And then making sure that you have the appropriate attributes in your data. So again, going back to this idea of different levels or layers of completeness, starting from all the way at the top with that overall checklist that you need to have of, hey, I've got all these layers, but then you have to drill down and go deeper and deeper into the data to make sure that it's accurate and complete. So you hear about this 98% standard of synchronization, okay? And that came from a document from 2009, okay, where Nina said, hey, you want to make sure that your MSAG and ALI are at least 98% synchronized with the databases that you have for your road center lines and your address points for the GIS data. Okay, now think about that. Think about what I told you earlier. What is GIS? It's geography and it's information. Okay, so that document effectively said, I want you to make sure that you have a 98% sync rate between your MSAG and ALI. Now, the MSAG and ALI are databases. 98% between the MSAG and ALI and the databases that support the GIS data. So the information, 98% sync between the information and the MSAG ALI databases. So you're leaving out a huge component. You're leaving out the entire geography part of the picture, okay, which is what's actually being used. Now, remember, I told you that was from 2009. It's a really old document, okay? So now we're introducing new facets of data management with introducing the geometry. Okay, so we're having to look at that as well, not just what's in the tables or the databases. So I've kind of beat this horse to death, but basically the data quality aspect is hugely important, okay? Doing that data inventory will help you understand a lot of this, especially the availability piece. Are your addresses being maintained by a department who doesn't like to share? Or the road center lines, or maybe they want to have total control over the data and you don't, you're limited on what you can do. You need to know that, okay? Because regardless of who maintains the master road center lines data set, you're going to have to provision something for public safety, or they're going to have to do it for you. Okay. So, is the data available? How accurate and complete is that data? We've talked about that at length. How often is the data being updated? Again, this goes back to workflow. You want to make sure that as soon as something happens in the real world that it's reflected within your data. And then, hey, am I using consistent data between systems? Am I using a 10-year-old GIS data set in my CAD, but I'm providing brand new up to date data for my 911 system? So this is the kind of stuff that you want to look at. You want your data to be consistent across all of the different systems. All right, let's talk about GIS data validation. So integrity is very important, and there are some tools within the toolkit that are going to identify anomalies within your data. Okay. What you're looking at here is called a fishbone. I know that's a weird term, but basically, what a fishbone represents is a visual geocode to its corresponding road center line. Okay. And what you want to see is something that's perpendicular for the most part or slightly slanted. Okay. Because what this says is that, hey, when I'm driving down the street and I get to a specific distance, I am at my expected point to basically stop in front of the structure where I'm responding. Okay, it's basically a geocode. All right. So that's why you want them to be perpendicular, because it basically says, hey, if I'm driving down a road, I'm going to stop perpendicular or close to the structure where I'm responding. All right. Where you find really vertical, tight V-shaped data, or where you see stuff that's in red, okay? That represents an area. Well, not red for it actually is not red in the toolkit, but you can identify intersecting road center lines, or intersecting fish bones rather. So if you have fish bones that cross one another, that tells you that you've got an address point that's backwards or out of range. Okay. But if you have stuff that's fish bones that are really tight and V-shaped, that means that you may need to adjust that road center line. Okay, so a fish bone is really valuable for a visual geocode of that data. So for PSAT boundaries, we talked about this earlier. You want to make sure that you're running the toolkit to identify any gaps and overlaps. That's critical. Okay, and you'll also have to look at your road center lines to identify where you have dangles. So anything that dead ends, like this line up here, if it if it's marked with a dangle at the end where it basically just dead ends, or if it's a cul-de-sac, you're going to have to mark those as exceptions. Okay, so is it a true dangle, or is it something where it's just a cul-de-sac and it really should not be an error? We need to make sure that it's not marked as one going forward. So the toolkit can help you identify those as well. Accuracy versus precision. We talked at length earlier concerning parcel placement, structure placement, access point placement. It's not wrong. It's not wrong to have an address per parcel. That's accurate. Okay. But it's more precise to say I have a structure point that goes with each structure. Okay, and again, that's something that you can work toward as a future goal. That's a really great job for an intern or someone who's new to GIS and they need to just start moving points. That is a perfect job for that person, okay? But We really like to see consistent data management. We get a lot of data sets where um, people have this mix. They're managing address points on top of structures. They've got them out in the middle of the roadway. They've got them in parcels. And there's different reasons for that, okay? But this is all part of your normal QC. This is not something that the toolkit can help you identify. This is basically just raw. I'm looking at the data. Maybe you divide it up into quadrants. Maybe you put a field on the end of your data and you start kind of going through and you're adding a field in and checking it whenever it's accomplished so that you know what addresses you've moved. But this is a very manual process that where you actually have to look at it. You have to look at each one individually and compare it to some aerial imagery. Okay. So you want to make sure you're using some good quality aerial imagery to help you. All right, now let's talk about the path forward and how we're going to manage data going forward. Creating sustainable data management. I've talked about this at length earlier, but sustainable data management goes back to workflows. If you pay a vendor to clean up your GIS data, even if they get it to a flawless condition, if they hand it back to you and you don't have a path forward, you don't have a plan going forward for how that data is going to be managed and maintained, you are going to, within a couple of months, have data that is decline in quality. Okay. NG911 GIS data management is not a one and done. It involves continual management, continual QC. And it's something that really needs to be built into a normal weekly database management or data management process. Okay. I'm not saying you have to run that toolkit every week, but the more you're editing data, the more you need to run that toolkit. Okay. So you want to make sure that you have a solid understanding of who's doing what within your org as far as data management, because the reality is that a lot of your data management is not just going to be in one department. You may have somebody managing addresses that's totally different than who's managing your road center lines. Okay. So you need to know that and you need to have the appropriate workflows established so that you're getting the information in a timely manner and that information is being entered into your GIS data and distributed in a timely manner. Updating your CAD system annually is really not a good thing. You want to make sure that you're also updating your systems on a regular basis. There's a lot that goes into this, which is why I'm very involved in leading strategic planning because the data tells a story, okay? And we can always tell what's going on with the data based on the workflows that are either established or not established, okay? So I don't want to, keep beating that to death, but the workflows are absolutely critical.
And I'll
Communication
say
oh,
too,
yeah, go ahead,
sorry,
sorry.
playing off of the workflows, when you are working independently, you might have your way of going about things and you might know, hey, this is my process in the day. But what if you were to hire another staff or have an intern support? You want to be able to pass over a documented process. Say, this is how we do it here. This is the expectation of what we're managing and have that kind of seamless integration instead of having somebody else come in and not really know what to follow, and then your data is out of standardization again, right? So I know you are a big advocate for workflows and documentation, Annie. Um,
Yeah.
I am too, obviously, right? So we just want to make sure we really drive that home.
Yes, absolutely. I mean, so many of you guys have this institutional knowledge that's just stored in your brain. And a lot of you may be nearing retirement and you just kind of take it for granted or take it, you don't really think about, oh, well, I know I'm the one who knows how to do this addressing. I've done it for 20 years. Well, who's going to take your place when you leave? Please try to get that out on paper. Please try to document everything that you're doing concerning that process because the next book, life has to go on, right? After you retire and you're on the cruise ship or you're golfing or whatever fun things people do when they retire, I won't know that for a really long time, but whatever it is you're doing, you want to make sure that the next person is set up for success and that you get that institutional knowledge out of your head and you document it somewhere. Okay? So I think that was a really good point to make. Um we do want you to take a proactive approach to data management. Okay? Reactive approach is often when it's too late. It's often when somebody comes in and says, "Hey, you know, we we had a structure fire last night and we couldn't find the place. It was at night and there were no lights. We couldn't see the smoke." Or even worse, a medical emergency, there are often no physical signs, right? So there's no smoke, there's no flames. Somebody's inside with a heart attack. You know, the data's wrong. The address points are not correct. The incorrect road name is up, or somebody's gone in and said, "Hey, yeah, you can name 3 different streets Mulberry Lane, Mulberry Court, Mulberry Terrace." Guess what? Those are all duplicates. I don't care that they have a different suffix. They are duplicate road names, okay? So avoid doing that. Take a proactive approach and actively identify this stuff and start fixing it. I understand that sometimes it's really hard to fix things in the real world. There's a lot of politics involved. People don't want to change their address, or maybe you don't have the authority to change an address because you don't know if you do, or you've never seen your addressing ordinance. But you have to start being as proactive with this stuff as possible. And again, this is all stuff that we're going to talk about in the addressing class, but I highly recommend that you take a proactive approach to this because if you don't, there could be real consequences. I mean, we had a client in the Southwest come to us because they had a fatality as a result of poor addressing in a mobile home park. So, I mean, this is very real stuff that happens, and nobody thinks it can happen to them until they end up on the news. Um, so make sure that you are QA/QCing your data. Take a close look at those fish bones. If you've got fish bones that are crossing or if you've got some weird stuff, have a workflow in place where your first responders can come in and report discrepancies in the data. That's beyond a post-it note. Stop doing that. Stop putting stuff on post-it notes and passing it around. Have a clearly defined workflow for communicating anomalies within the GIS data or within stuff that you're seeing in real life. Okay? And remember that you are geospatial first responders first and foremost. So addressing is for public safety. Don't let anybody tell you any differently. Anyone else outside of public safety, they're just a consumer of that data. The whole point and purpose of of an addressing system is to get our first responders where they need to be efficiently and as clearly as possible. Okay. The same with our PSAP boundaries. It's to get the call routed to the appropriate PSAP the first time. So all of this stuff takes a lot of research in how this data is going to be managed, a lot of thought, a lot of bringing stakeholders together. Do we need to transition authority from one agency to another? All of that stuff is stuff that you have to look at. All right, so some best practices. You want to maintain the required fields. We've already shown you what that looks like in the standard, and the toolkit is also going to help you understand if you've missed something by flagging different anomalies or different things that are missing in the data. Be mindful of how other features impact data attributes. So things like making sure that you're representing your ESN or your community information within your data. Like I said, even though something may not be required within the data, if you have it, you want to go ahead and populate it. Okay. Make sure that you are keeping a close eye on your address points and your road ranges. If you are adding an address point in, make sure that your road ranges encompass that address point. You want to make sure that anywhere you have an attribute change where a road center line crosses, that you're breaking that road at that boundary or where that attribute change occurs. Parse the address elements, like I said before, that involves taking each piece of an address and dividing it up into individual fields. You'll want to make sure that you're standardizing those attributes as much as possible. Okay. that is critical to managing data and also on the consumption side for NG911. It has to be standardized. Domains, we talked about that at length earlier. Domains are critical to reduce inconsistencies and errors and that kind of fat fingering that happens with folks sometimes. And then you want to use true nulls, and Becca's going to show you guys how to populate true nulls so that you don't have blank values. And we'll talk about that in our GIS data actual desktop class. Creating a QA culture is extremely important because it's proactive in that it helps you correct things that are wrong, but also helps to enforce the best practices that you establish. You have to have stakeholder engagement, like I mentioned before. Whoever is assigning addresses or managing the address data may not be the same agency that's managing the road center line data. You may even have an addressing authority that is only assigning a primary address, but leaving the sub addressing up to someone else. Okay. So I've seen things kind of get a little strange depending on who I'm working with. And this is nationwide. It really there's really no rhyme or reason to how things are organized in some places. It's just that you have these entrenched legacy workflows that are not really true workflows, but just kind of like the way things are being done. And a lot of it doesn't make any sense and needs to be tightened up for next gen 911. So understanding who manages that data, like I said before, doing a data inventory can be very, very valuable in helping you identify the management and maintenance of that data. NG911 education is extremely important. I don't want to knock our planning folks. Planning and zoning folks are incredibly important, community development. But the reality is, they probably do not understand the reasoning or best practices for assigning addressing for NG911. Remember, I told you earlier that GIS emerged as a planning and land management tool, and it's it's remained there for a lot of places. So addressing is still done in planning, road center line management. So just be aware that you may need to get in and educate some folks, especially if you're not willing to take on that responsibility of maintaining that data. You're going to have to educate these people, okay? You're going to have to get them into these different classes if they're not public safety folks because it's going to be incredibly important. The workflows we've already talked about. I've already mentioned how you need to do validations on your NG911 data on a regular basis. And you may need to do it more frequently if you have more editing. Okay. So, Becca, did you have anything that you wanted to add?
I'll just reiterate the iterative process, right? Because I'm big on QC and I'm big on um, having processes in place. So even if it's just you working alone, have some sort of structure where okay, the end of my workday, if I'm spending several hours editing or adding features, I should have a QC process at the very end of my workday or at the end of my week, just to go through and look for things that you need to check. Because, like you said, Annie, every time you add a feature or edit a value, one of the attributes, there's a potential you might be creating a discrepancy that could cause a lack of synchronization between either your MSAG and alley tables, between your address point and road center line, know how they need to be communicating, moving something that could be outside of a boundary or inaccurate with the boundary. So there's a lot of things that could flag as issues if you're not practicing mindful editing and implementing a QC process, like an iterative process. And we're going to talk a lot about um, some easy QC practices as we get into the editing portion of this recording. So I'm going to show you some ways to visually QC your data and also to find discrepancies within your data, as well as when we do the toolkit course. The whole intention really at the end of the toolkit is to validate your data. So we're going to really drive the QC aspect home.
Awesome. Really good points, Becca. Thank you for your input. So, this concludes the PowerPoint portion of our Intro to GIS class. Again, if you have any questions, please feel free to reach out to us. And we are going to also now create the editing portion or the ArcGIS desktop portion.